For today's topic, we will be discussing what happens when you purchase a device, be it the controller or the WAN edge routers. What happens when you purchase it? What is required for you to bring it onto the SD-WAN fabric? So this is pretty much from the scratch that is we are going to discuss today. Yesterday, we discussed that each and every device that is added to the SD-WAN fabric needs to be authenticated with VBond in order to get added to the SD-WAN fabric, right? So what exactly VBond checks when it authenticates the devices? We will be discussing that today, and we will be discussing about the authentication between vManage and VBond. Similarly, vSmart also needs to be authenticated to VBond. We will be checking that as well. Apart from that, both the controllers vManage and vSmart also authenticates with each other. Moving ahead, we will see how vEdge is authenticated by VBond before it is added to the SD-WAN fabric, how vEdge is authenticated by vManage, and what are the factors that vManage check when it authenticates. Moreover, we will check how vEdge is authenticated with vSmart. We discussed yesterday that there is certain minimum configuration required on each and every SD-WAN device. So we will be discussing what is that minimum configuration and what is the use, what exactly those commands does. Apart from that, we will also be checking what exactly is certificates, what is the use of certificate, why it is needed, and who provides it. So for today's lecture, this is the topic that we are going to discuss. So each and every device comes with a serial number and the model. Each and every device has a serial number and a model number. So when we purchase a device from Cisco, what Cisco does is it creates our ID on their portal, on their PNP portal. So it creates our ID on their PNP portal and adds this serial number and the model, add these device details against our ID. So let's say Azim has purchased a device and he has this serial number and model number of it. Now what Cisco will do is Cisco will provide an ID for this guy, and under that ID it will add the device that he has purchased. Apart from that, apart from adding the device, it also adds the controllers that he has purchased. Moreover, it also has the organization details for which this guy works. And this organization detail is also used to authenticate. Okay. So there are two types. When we log into Cisco portal, when we purchase this device, we need to bring this device to the vManage so that vManage knows which devices do we have. So let's say we have 100 devices. So all 100 devices can be added to vManage in two ways. One is via serial.vipela file. And the second one is via syncing the smart account. Okay. Now, what is serial viptela file and where do I get it from? So when Cisco adds these devices, all these 100 devices on their portal, what we can do is we can navigate to that portal and download this file. And this file will contain all the serial number and model of all these 100 devices. This serial viptela file, we can go to the vmanage from the configuration and devices tab, configuration and devices tab, we can add this serial viptela file. And once we do that, vmanage will get the list of devices and the controllers this organization has. This is method one. Second method is by syncing the smart account. As I said, that whenever we purchase the device, one ID is created, and under that ID, all the device list is added. And this smart account, this is the ID, and which is also known as smart account. We can simply go to vmanage and sync that smart account. And once we sync that smart account, all the devices, all the 100 devices or whatever the count of the devices is that we have purchased will be available in the vmanage. So let me quickly go ahead to vmanage and show it to you. So there are two ways wherein we can check the available devices. One is of course the GUI method and the other one is CLI method. I will be showing you all both the methods. So this is the vmanage. If I open Linux machine, and with this Linux machine, I will be accessing the vmanage. I will open this Linux machine. Once I open the Linux machine, I will go to the web browser and type the IP address of the vmanage to get the access of the vmanage GUI. Once I do that, I will go to configuration and devices. This is where I will get the list of devices. So when I get serial.viptela file, what I will do is I will simply go here and upload that vanage list. And once I do that, from here we can browse it and we can upload it. And once I do that, I will get all the list of devices that is purchased by me and that is under my organization. And the other way that we discussed by syncing the smart account, you can simply click over here. Enter the username and the password that is given by the Cisco. And once we sync it, all the WAN edge devices that is purchased by the organization will appear here. As you can see, that organization named sianets. Sianets has these many devices, purchased by them. So this is the graphical way of doing GUI way of looking at the devices that we have purchased. If we have to look at the CLI way, what we will have to do is simply SSH into the vmanage. and type show control valid V edges. By doing this, we will get the list of devices that is purchased by our organization. You will get the serial number, you will get the organization name over here, and so on. So once we do this, once we either upload the serial Viptela file to our vManage, or either we sync our smart account, vManage knows how many devices to be expected to the SD-WAN network. But we discussed that vBond is the authenticator who authenticates each and every device to the network, right? So what will happen is when vManage and vBond authenticate with each other, this vManage will share this list of devices with the vBond, and post that vBond will be the authenticator for any of the devices. So let's see what happens when the vManage and the vBond authenticates. So even in the real environment, if you purchase any device, this is the method that you will be using to upload your devices onto the vManage. And each and every one of you all who is going to work on SD-WAN will have to go through this process. So now what happens when the vManage and the vBond authenticates with each other? So let's say this is my vManage, and this is the vBond. Okay. In order to authenticate with the vBond, what vManage will do is vManage will first send a client hello message. This client hello is to open a authentication sequence with the vBond, to which the vBond will revert with hello verify request. vBond will tell vManage to verify the hello request. After that, the vManage will again send a client hello request, to which vBond will revert with server hello and the certificate details. Now, vBond will also request for the certificate of vManage. Since there is a mutual authentication between vManage and vBond, both of them will authenticate each other with the certificate details. Now, vBond will again ask for, vBond will share a server hello done message, and it will request for the vManage certificate. To which vManage will also share its certificate with vBond. Now, vManage has the certificate details of vBond. Similarly, vBond has the certificate details of vManage. Now, what vManage will do is vManage will extract the serial number, the organization name, and the certificate root CA details. Root CA details from the certificate provided by the vBond. Similarly, vBond will also extract the serial number, the organization name, and the root CA details from the certificate that is provided by the vManage. Now, if the serial number of the vBond matches with the serial number that is being purchased by the organization, it will take it. Once it verifies the organization and the root CA, it will come to know that this is a legitimate vBond which is supposed to be on this SD-WAN network, and it belongs to their organization. Similarly, vBond will also verify the serial number of the vManage, the organization detail of the vManage, and the certificate details. The certificate which is signed by root CA is legitimate or not. And once it verifies these details, it will say that yes, this vManage belongs to our network, and then vManage will push the device details, the vEdge and the other controller details. As we discussed, that we put the edge device details and the controller details to on vManage. Once they both are authenticated, these details vManage will share with vBond, because vBond is first point of authentication to any of the devices. So those details needs to be present with vBond. Even vManage is the first point of contact, is authenticating to the vBond first. So those details needs to be be with vBond, and hence vManage will give those details to vBond. And if we go over here, so if we go, let's do a quick packet capture to see whether all that we discussed is right or not. So I've turned off the vBond as of now. Waiting for this vBond connections to get deleted. Once this is done, we will do a packet capture from scratch and verify all the certificate details that we have discussed. So let's turn this off. Okay, it will take some time. Meanwhile, we'll go ahead with the other authentication, and then we will look for the packet captures. So similarly, just like the vManage is authenticated with the vBond, vSmart will also authenticate itself with the vBond. So there will be certain packet changes between both of them that we are going to discuss now. And the authentication method will be similar to that of that we had with the vmanage and vbond. So in the authentication between the vsmart and vbond, vsmart will be the client over here, and vbond will be the server. vsmart is the one who initiates the connection. So as soon as the vsmart is turned on, what it will do is it will try search for the vbond ip, and once it gets the vbond ip, it will send a client hello request, to which the vbond will again share a hello verify request. Upon receiving this hello verify request, vsmart will again share a client hello request. Then the vbond will share the server hello message along with its certificate. Now vbond will again request for the certificate request of vsmart, and it will share that the server hello is done. Then vsmart will share its certificate with vbond so that vbond can authenticate vsmart. Again, now vbond has the server, vbond has the detail of vsmart, and vsmart has the details of vbond. Now vsmart will extract the serial number, organization details, and the root CA details from the certificate. It will verify whether it is right or not as per the details provided. And again, vbond will also extract the certificate and look for serial number, organization, and certificate root CA details. Once the vbond verifies that yes, these details are correct, it will give rights to vsmart to get added to the network, to the SD-WAN fabric. All right, so let's move ahead and check this as well in our packet capture. So what we are going to do is we are going to have a quick packet capture on the vsmart and vbond and verify this authentication sequence. We've turned our packet capture on for vmanage. Let's do it for the vsmart as well. Okay, so vmanage IP is 10.110.1.10. vbond IP is 10.110.1.11, and the vsmart IP is 10.110.1.12. So when we go to our packet capture, we can see that it is trying to, if we do an ARP filter, it is trying to find who is the vmanage is trying to find who is 10.110.1.11. It is trying to find because the vbond itself is down as of now, and as soon as we turn on this vbond, it will get the IP of the vbond, it will get the reply from this vbond, and the authentication will begin. Okay, so we can also verify that this is from vmanage and it is looking for the IP address, and it is also trying to tell that the vsmart is also looking for the vbond IP. All right, now let's go ahead and turn on the vbond. Okay, now we can see that the authentication has started to happen. See, we can see that the authentication has started to happen between vmanage and the vbond. If we filter this packet capture with the IP address of vbond, remember that this packet capture we are doing on vmanage. So if we search the IP address of vbond, we will see that there are certain packets being sent. So first, as we discussed, that it will vmanage. Let me clear this. See, we can see that the vmanage is sending a client hello request to vbond, as we discussed in the previous stage. Then vbond is sending a hello verify request to vmanage, to which vmanage is sending again a client hello to the vbond. And now we can see that after server hello, vbond has sent its certificate. Now let's see what is inside this certificate. Now we discussed that vmanage will extract this certificate and it will look for the serial number and the organization and the root CA certificate details. So let's see if that is right or wrong. If we open this certificate, we can see that under DTLS, we will get a certificate. And if we open this certificate, we will see that the organization name, we will see that sianets, the organization name. And this is the serial number of the device of the vbond. And it contains the other certificate details as well. And these are the total certificate. Similarly, we can see over here that vmanage is also sending the certificate over here. This is the vmanage IP, and vmanage is also sending its certificate to vbond so that it can authenticate itself. So let's open this certificate as well and check. Under DTLS, we'll open the certificate details, and here is the certificate. This is the organization name. And here are the serial number details. That this is vmanage and this is the vmanage serial number details. And if we go to the vmanage and see whether this certificate is installed in or in the vmanage or not, we can also check it. So if we go on the vmanage and do show certificate installed, we will get the certificate that is installed. And this is the serial number. As we can see, we also verified in on the packet capture 4145 ending with 4145 is the serial number. Let's see that as well. Ending with 4145. 711274145. Even here we can see that 711274145. Apart from the serial number details, it also has organization name and the location where this device is hosted. We can also see in the certificate details, it also has the validity. So this certificate is valid for 1 year. And after 1 year, we will have to renew it. And I will also show you all the procedure how to renew it. So that in case if you all came across a situation where you'll have to renew a certificate, you will be able to do it. And this is the issuer details. As we said that this certificate has to be provided by some root CA, which VBonds checks. So this is the issuer details that it verifies. And this is the public key of the certificate. Let's go ahead and check for the vSmart, the authentication between the vSmart and vBond as well. So this is my vBond. Let me stop it. Then 1101.12 is my vSmart, as we can see over here. Then 1101.12 is the vSmart. Okay, here is where the authentication begins. vSmart, as we discussed, that vSmart is the server. A client. It will begin the authentication with the vBond by sending a client hello, to which the vBond will share hello verify request, send hello verify request to vSmart, and here is that packet. Again, the vBond will again share the server hello. The vBond is sending the server hello along with its certificate. Now vSmart will extract this certificate, look for the serial number, organization name, and the root CA details. Once it verifies these details, and if that is right, the authentication between vBond and vSmart is done, and vSmart is now provided the rights to be added into the SD-WAN fabric. So this is how the authentication between the controllers are happening. Let us go ahead and check for the other authentication as well. So we have looked for the authentication between the vSmart, vmanage and vBond, and vSmart and vBond. Let's look at the authentication between the vmanage and vSmart as well. So all these controllers will authenticate with each other before being added to the SD-WAN fabric. And the process for authentication of all the controller is same as we discussed for vmanage and vBond. The vmanage will initiate a connection with the vSmart by sending a client hello, to which the vSmart will share hello verify request. Again, the vmanage will share client hello, to which the vsmart will send server hello done along with its certificate, and it will also request for vmanage certificate, to which the vmanage will send its certificate to vsmart, and then the authentication, the checks begins by both vmanage and with the vsmart. And we will also see that in the packet capture, the captures that we have already taken, we should also see it over here. Stop it. Okay, so this is my vsmart, and if I look for the IP address of my vmanage, I will see some data is being shared between both of them. And again, we can see that vmanage initiates the connection this time with, okay, this is for one dot. Okay, so this is my vmanage. So we can see that my vmanage is initiating the connection with the vsmart, as the vsmart IP is .12, to which my vsmart responds with hello verify request. Vmanage again sends the client hello, then vsmart sends the hello server hello done and the certificate. Vmanage will now extract this certificate and look for the serial number, organization, and the root CA details. We can also see that the packet size is more than 1500 bytes, so it is being fragmented. So this is also one of the interview question. What happens when the packet size becomes more than 1500? So the fragmentation is done over here. Moving ahead, vmanage sends its certificate to vsmart, then vsmart does the checks on those certificates, and once it is done, the vsmart and the vmanage is added to the SD-WAN fabric. Once the authentication between vmanage and vsmart is done, what will vmanage do is vmanage will share the configuration. So all the configuration is done on the vmanage, right? Be it vsmart, be it the controllers or the edge devices. So once that is done, it will push the configuration to the vsmart under the tunnel. So if we go ahead and check for those configurations, we will not be able to see any details because it is being sent under the tunnel and those details are encrypted. So here we do not see any details. All the details we can see that encrypted application data. So we will not be able to extract these encrypted details. So it will push the configuration to vSmart, and it will also push the policies to vSmart. So this is how the authentication between vmanage and vSmart is done. The authentication process for vEdge and vBond is also similar, and there is just only one difference between all of them. So let's go ahead and check that as well. Okay. So each certificate has two keys. Whenever a device is allotted with a certificate, it will have two keys. One is a private key, which no device shares with any of the devices. And the other one is public key, which can be shared with any of the devices. All right. So when the authentication process between vEdge and the vBond begins, my V edge will initiate the connection to VBond. There is a slight difference between the authentication that has happened between the controller and VEdge, and we will check those difference here. So VEdge will send client hello request. VBond will share hello verify request to initiate the connection. It will again send a client hello request, to which server will share server hello done certificate, and it will also share a random number. It will encrypt this random number with its private key. As I said, each certificate has a private key and a public key. So this random number is now encrypted with the private key of VBond. And those who have the public key of this VBond will be able to decrypt this random number. Since VBond is sending its certificate to VEdge, along with the certificate, it also shares the public key. The public key is present in this certificate itself. So this is just for testing whether the VEdge is able to decrypt the data or not. So along with the server hello done and the certificate, it will encrypt a random number with its private key and send it to VEdge. And it will also request for VEdge's certificate. Now, VEdge will share its certificate along with the decrypted random number. Now, the VEdge has the certificate of VBond. It will check the serial number. In this case, it will not check the serial number because VEdge does not have the serial number details of VBond. We have not, from vManage, we have not shared it to VEdge. So it will simply check organization name and the root CA details. Upon receiving the certificate, VBond will check the serial number, organization name, and the root CA details, as well as the random key. So while sending, it will also share the decrypted random number, right? So it will also verify the VEdge, whether VEdge has decrypted the random number correctly or not. And if this all parameters are checked and if it is correct, VEdge will be authenticated by VBond, and it will be given the permission, the rights to be added to the SD-WAN fabric. Once it is authenticated with the VBond, VBond will share the IP address of the vManage and the vSmart to this VEdge. And that is how VEdge know how to reach the vManage and the vSmart. Before that, it does not have any details of the vManage. Neither it has the details of the VBond. We do it with the help of minimum configuration. We tell VEdge the devices how to reach VBond. We will discuss about the minimum configuration later in this session. So once the VEdge is authenticated with the VBond, VBond will give the vManage and the vSmart IP details to the VEdge. Apart from doing that, VBond will also tell vManage and vSmart that you will expect a connection from the VEdge. So VEdge will then initiate a connection with the vManage. It will try to authenticate with the vManage. The process will be same for authenticating with the vmanage as well. Vedge will share a client hello message to which vmanage will share hello verify request. Again, Vedge will share a client hello along with the, and then the vmanage will share server hello done along with the certificate and the random number. Each controller will share a random number, encrypted random number to the Vedge, and it will wait for the decrypted number from the Vedge. And after that, it will also request for Vedge's certificate. Vedge will then share the certificate along with the decrypted random number. Vmanage, similar to the vbond, will open the certificate of the Vedge and look for serial number, organization name, root CA details, and it will verify whether the decrypted random number is right or not. Over here, Vedge will also verify the organization and the root CA details. Once vmanage verifies these details, and if these details are right, vmanage will push the configuration to Vedge. Apart from pushing the configuration, it also starts monitoring its health, the CPU utilization, the memory utilization, its environment details like temperatures and all. And apart from doing this, it will also push the configuration. Apart from pushing the configuration, if there is any other localized policy configured, it will also push it. And it will push all the configuration via netconf protocol on TCP port 830. These are all interview questions as well. So if you are well versed with this process, you will be able to answer these questions as well. So once this is done, my Vedge will start functioning and it will start forwarding the data packets. The third authentication is between the Vedge and vSmart. The process is similar. It will send a client hello to which the vSmart will send hello verify request. Vedge will again send a client hello request to which the vSmart will share server hello done along with its certificate, and the authentication is pretty much similar. Once the authentication is done between the Vedge and the vSmart, there are vSmart will push the centralized control policy to the Vedge. These centralized control policy will be pushed to Vedge via OMP protocol. And again, it uses TCP port 830. Apart from this protocol, this configuration, the policy will be pushed under an OMP tunnel. So what it will do is the Vedge and the vSmart will form a tunnel, DTLS tunnel. Under this tunnel, they will also form a OMP peering. And under this OMP peering, all these policy updates will be shared via OMP updates using TCP protocol 830. Now that we have discussed about the authentication, let's go ahead and check the packet capture. Okay. Okay, let me turn. Stop. Okay, this will take a while. This router will take a while to turn on. So by the time we are waiting, once the vSmart authenticates the vEdge, it will push all the policies. And apart from the policies, the vSmart also share two important things, which is IPsec keys. These IPsec keys are used by the branch routers, the routers, to form a BFD tunnel between the branches. So let's say this is branch 2 and this is branch 1. Once it authenticates with the vSmart, once this branch 2 is authenticated with the vSmart, it will share the IPsec keys of branch 2 with the branch 1. Similarly, it will share the IPsec key of branch 1 with branch 2 so that they can form a BFD tunnel with each other. Apart from this, number 2, it will also share the V routes details. So if we come to our topology, there are certain VPNs configured connected between this branch, and there are certain VPNs configured behind this branch as well. So what branch routers will do is, once they authenticate with the vSmart, they will share these details with the vSmart. Now vSmart will do the calculation on how to reach this branch, the best part to reach this branch, and share with this router. Similarly, the vSmart will again do the calculation on how to reach this branch, what is the best path to reach this branch, and share it with this router. So there are three important factors that vSmart does after authenticating the vEdge. It will push the policy configuration via OMP peering. Number 2, it will share the IPsec keys so that they can form a BFD tunnel. And the third one is, it will share the V route, the OMP route details on how to reach the V routes, which is the best path to reach the V routes of other branches. Right. So let's do a quick packet capture on this as well. See, it is looking for the vBond IP address. It still does not have the vBond IP address because we have turned this router off. So as soon as I turn this router on, it will start authenticating with vBond first. Then it will get the vManage and the vSmart IP details. Once it is authenticated with the vBond, then it will form the tunnel. It will form the try to authenticate with vmanage. Once it is done, it will get the configuration details, and this router, this vmanage will start monitoring the health of the device. And after that, it will try to authenticate with vsmart, after which it will get the IPsec keys to form the BFD session, the vroute details of other branch routers. So let's go ahead and turn this router on. Okay, we can see that the client hello is being shared between 1070.1.1, which is this router. Okay, we can see that the IP address is 1070.1.1 of interface 0/1, and it is BR London. So if we open the packet capture, we can see it is trying to authenticate with the vBond, sending the client hello messages. This client hello was being sent continuously because it was not able to get the revert since the router itself was off. Once it got the hello verify request, the authentication begin. Here is the certificate details that is being shared. We can see that the certificate is being shared, and it is also requesting for the certificate of VH. vBond is requesting for the certificate of VH. If we go down, we can see that the VH 1071.1 is the VH is sharing its certificate to vBond. And if we open this packet, we will see the organization name and the common name, the serial number of this device. If we go on BR London and see show certificate installed, we can verify it from here, ending with 6A93. Ending with 6A93. This is the serial number. And this is the organization name. And the certificate itself has the root CA details. After authenticating with the vmanage, it will authenticate with, after authenticating with the vBond, it will authenticate with the vmanage as well. See, we can verify it with the sequence number. With vBond, the sequence was somewhere around 300, meaning it authenticated with the vBond first, then it authenticated with the vmanage. See, we can see that the client hello has sequence number 808. Again, the vmanage authenticated itself. Both of them authenticated each other, and then it authenticated with the vsmart. We can verify it from the sequence number as well. And when we go to our vManage, we will see that the vManager started monitoring its health status and all. Okay, we can see that it has started monitoring vSmart details, VH details, and vBond details. If we go ahead in the devices tab, the network tab, we will see the CPU and the other details as well. Here it shows the temperature of the devices and other environment details. Since this is the virtual device, we will not be able to fetch those details since the virtual device does not have any temperature and all these details. So it will not display over here, but in the actual environment, you should be able to see those details over here. From here, we can verify the other details as well. Okay. So this is how the authentication between each other, between the VHs and the controllers happens. So we were discussing about that each and every device needs to have minimum configuration so that they can know where and how to reach vBond and other controllers. So what is this minimum configuration? So let's go ahead and check what this minimum configuration actually is. So these are the minimum configurations. First being the site ID. This is similar to the site name. Let's say we have a hub which is hosted in Delhi. Earlier we used to name it with the branch name itself, but here we will have to have a site ID with it. So we give a numeric site ID, and it can range from any number, starting from 1 to any numbers. And this site ID is also used to avoid loop in the network. No site ID, no two branches can have similar site ID. For example, there are two branches. One is in Mumbai and other one is in Delhi. These two branches cannot have similar site ID. Both of them have to have a different site ID. The second one is system IP. System IP is similar to the router ID. The router ID that we have in the routing protocols, say OSPF, it is similar to the router ID. And again, no two routers will have similar router ID. For example, I have a router in Mumbai and my other router is in Delhi. I have given this router ID, this router as a site system IP of 10.10.10.1, and I cannot give my Delhi router as the system IP of 10.10.10.1. It has to be something else, either 2, 3, whatever it is, it has to be different. Now, this is where we tell device what is the vBond IP, and this is how the WAN edges and the controllers know where to reach to find the vBond IP. So we give this vBond IP so that the device, the V edge or the controllers know where to find the vBond. Even in the packet capture, we saw that the devices were looking for 10.1101.11. That is because we have defined this vBond IP on the router or on the controller. Organization name, we have it sianets in our case. So this organization name has to be same on each and every device and each and every controller. And this is case sensitive. So while putting the organization name, we need to be careful. If we put any wrong organization name, that device will not be able to come up in the SD-WAN fabric. Since the authentication itself will fail, it will not be able to come on the SD-WAN fabric. Moving ahead, VPN 0 is also known as transport VPN. And on the VPN 0, let's say we have a router. We have this interface as GI 0/0/0, and this interface as GI 0/0/1. And we will be having our WAN connectivity to these interfaces. So both these interfaces will belong to VPN 0. So VPN 0 is transport VPN where the WAN itself is connected, and the interfaces on which the WAN is connected will belong to VPN 0, which is transport VPN. VPN 512 is out of band VPN. It is designed for out of band management. Apart from this VPN 0 and VPN 512, any other VPN number from 1 to 511 and from 511 to any number XYZ. These will be my service routes. Some of them also call it as V routes, and some of them also call it as OMP routes. So do not confuse yourself when you hear all these terms. All these three terms are one and the same. Anything between VPN 1 to 511 and between 511 to any number, these routes will be service routes, V routes, or OMP routes, and all of this is one and the same. And the last one is certificate. Each and every device has a certificate, need to have a certificate installed on it, because this certificate provides the authenticity of the device. Apart from providing authenticity of the device, it is also used in the authentication process. Each controller or VH will have to have this certificate installed on it. If certificate is not installed or if the certificate is not legitimate, not right, it will not be able to authenticate itself and it will not be able to be added in the SD-WAN fabric. So these are the minimum configuration which is done on the controllers as well as on the WAN edge devices. Moving ahead, we will be discussing about the certificates. We have seen that we have been using these terms certificates quite often in this authentication process. So moving ahead, we will discuss about the certificate. So now what is this certificates? Certificates are used to provide the authenticity of the device. Just like all Indian citizens have Aadhaar card, and this Aadhaar card or PAN card says that he is a citizen of India, he is a legitimate citizen of India. Or if any other country has any may have some other card, but Indian citizens have Aadhaar card and PAN card to prove that he is a legitimate citizen of India. Similarly, these certificates provides the authenticity of the device. It states that this device is legitimate device, and it does not belong to any hacker. Now, who provides this certificate? Since the Indian government have, there are state governments, and state governments are responsible for providing these Aadhaar card to the residents of their states. Similarly, the certificate has root CAs. Root CA has in intermediate CA, and enterprise CA. Now, these intermediate CA and root CA has rights to provide the digital certificate, the certificates to devices. And if we go on the device and do show root certificate, we will see there are multiple root CAs added to the devices. Let's go in any of our branch router and do show root CA, show certificate, root CA cert. We can see there are many root CAs added into this device. And apart from that, we also have a sianets as a root CA because we are using enterprise CA over here. We can see that sianet is also one of the enterprise root certificate who has the authority to provide certificate to the devices. Now, how to get this certificate? So to get this certificate, we will have to generate a CSR. Now, what is CSR? Let's go to the whiteboard. CSR consists, so if we go to get a Aadhaar card, we will have to provide our name, our address, our date of birth, electricity bill of the resident, etc. Similarly, to get a certificate for the devices, we will have to generate a CSR. Now, CSR consists of name of the device, which is also known as CN in the certificate, the organization unit, the organization name, the location where this device will be installed. Location consists of country, state, and the locality. Now, we will have to generate this CSR. After generating this CSR, we will get two items. One is CSR and the other one is the private key. This private key is not to be shared with anyone. This private key, we will keep it with the device itself. And this CSR, we will give it to the root CSR, root CA, so that they can sign this and give us a digital certificate which we can install it on the device. Now, how will the root CA provide us the certificate? What will the root CA actually do on this CSR to provide us with the certificate? Now, root CA have their own private key. Upon receiving this, they will run a hashing algorithm of SHA 256 on their private key. After doing this, they will get a X value. Upon this X, they will run a encryption, AES 256 encryption, and this encryption can be different as well, to get a Y value. This Y is nothing but a digital signature. And on this Y, they will, on this digital signature or on this Y factor, they will add our CSR. And this will give us the digital certificate. So root CA will give us this digital certificate, which we can go ahead and install it on our device. So this is how the entire process is. So if we go on the device, we will see the certificate details. Let's go and verify on few devices. Show certificate installed. So this is the certificate wherein we have CN, which is the name of the device, and it will have the serial number. It belongs to, this device belongs to Viptela and it has been purchased by Sianets. It belongs to the location San Jose. Country is US and state is California. We can also view the certificate validity from here. We can also see who is the issuer of this certificate. In our case, it is vmanage. Since it is enterprise CA, we will be vmanage will be the enterprise CA for us. And here is the public key as well. Private key will not be visible over here. So these are all the details that we have in the certificate. Apart from that, we can also see the encryption method that they have been using. Let's go ahead on vmanage and check the same. The country, the state, the locality, organization unit, organization, common name, which has the serial number and other details. This is the public key. And here is the validity. So if it before December 21, we will have to renew it. Okay, so to renew it, we will have to generate a CR and provide it to the root CA to sign it and give us the digital certificate. Now, how do we generate a CSR? Let's go ahead and check that as well. If we go to the vmanage, we will go to configuration, certificates. Then go to the controllers. Let's say we want to renew the certificate of vSmart. We will select this vSmart, click on the three dots and generate the CSR. Once this CSR is generated, we will download it. We will download it and share it with the root CA to sign it. And once we get it, we will simply come here, select it and upload that certificate from here. We'll select the device, install certificate, select a file that is locally available. We will have to make that certificate locally available, select the file and install. And that should be all to renew your certificate. Let's head to the content that we were discussing. So for today's topic, we have discussed all of this. Let's move ahead to our notes. Here is the notes of what we have discussed in today's session. So we have discussed about the authentication between vmanage and vbond, vsmart and vbond, vmanage and vsmart, vh and vbond, vh with vmanage, and finally vh with vsmart. We have also discussed what happens when we purchase the device, how to bring it till the vmanage, how to upload or how to sync our smart account with the vmanage. Apart from that, we have discussed about the minimum configuration and the certificates.